Today we're going to be talking about the surface area of prisms and cones, or I'm sorry, pyramids and cones. I was thinking about yesterday's lesson, which was prisms and cylinders. So, a pyramid. Pyramid has a base that is typically a regular polygon. I think in most of our cases it's going to be a regular polygon. So I have a square base here and lateral sides that are triangles. So each one of my sides, and let me highlight one here. That's going to be a triangle. Where all the triangles meet, that's called the vertex. I think I've actually heard some people call that the apex. I could be wrong. The lateral edge is where all the lateral sides meet. You have the altitude, so that's from the vertex down perpendicular to the base. I might be calling that the height sometimes. You have a base edge where the lateral sides and the base meet. Now you have a new piece here, the slant height. The slant height goes, and it's along one of the lateral sides. It goes from the vertex perpendicular to that base edge. So if you were looking at one of those sides, one of those lateral sides, it's from the vertex perpendicular. So it's kind of like the altitude or the height of the one of the sides, and that's called the slant height, and we're going to be using that a lot today. Our book uses a cursive L to denote slant height, so that's what I'm going to be using. Okay, surface area of pyramids and cones. The lateral area of a pyramid. So this is a pyramid when it's all put together. This is called a net. Basically, if I were to like cut along all the edges and kind of fold it out flat, you see that each one of these sides is a triangle. So the lateral area is 1/2 the slant height, because that's the altitude, times by the side length, times by the number of sides. Now remember, the side length times the number of sides, that's the perimeter. So our lateral area is 1/2 the slant height times by the perimeter of the base. Okay, so let me write that out. One half the slant height, and then times by the perimeter of the base. Now the surface area is going to be whatever my lateral area is, plus B. Remember, B is standing for the area of the base. Okay, so you need to remember those two formulas. And remember, we're going to be having regular polygons here for the area, for the base. So you're going to have to figure out how to find the area of that base, and that area formulas are going to come from the previous chapter that we just did. Okay, find the lateral area. So again, I would recommend we write out the formula. Lateral area is 1/2 my slant height times by the perimeter of the base. They tell me it is a square pyramid. So that means that I can imply that all these sides of the base are 2.5. So my lateral area is 1/2 my slant height is that segment there, so that is 5. 1/2 times 5 times the perimeter of the base. Well, I have 4 sides, and they are each 2.5. Plugging that all in, we get 25 centimeters. Since I'm talking about area, it's units squared. Okay. Find the surface area of the square pyramid. Give answer in simplest radical form. Okay, so Surface area is going to be our lateral area plus the area of the base. So let's first find our lateral area. So our lateral area, actually I'm going to erase that base piece for a second because I think I'm going to need a little more room. 1/2 my slant height. My slant height is here. I'm not given that length. I'm given that this is 6 and that is 4. So let's look at that triangle. I have 6, I have 4. I'm trying to find my slant height. So L squared is 6 squared plus 4 squared by our Pythagorean theorem, because we have a right triangle. L squared is equal to 100. That means that L is equal to 10. So 1/2 my slant height times by the perimeter of the base. I have 4 and they are each 8. So my lateral area, I apologize, I actually messed this up. I thought it was, it's not that. I just looked at my notes. This is 52. This is then the square root of 52, which, pulling out some perfect squares, that is 2 root 13. I apologize. Good thing I caught that mistake and I looked at my notes. Okay, so now multiplying all that together, we get 32 root 13 square meters. I need to find the area of the base, which is 8 times 8, since it is a square, that is 64. So my surface area is 64 plus 32 root 13 centimeters squared. I don't know where I got centimeters from. Ooh, I'm not doing too well on this example. Let's move on to the next one. Surface of the regular hexagonal pyramid. Okay, so let's first find our lateral area. 1/2, they give me the slant height is 15, times by the perimeter of the base. It's a hexagon, so I have 6 sides. They're each 10 centimeters each. So my lateral area is 450 centimeters squared. Now I need to find my surface area. Each one of the sides of my base is 10. If we draw down, if we draw our triangle in there, this side is 10. If I drop down my apothem, which is from my center perpendicular to my base, remember that cuts that side in half. So I have a 5 there and a 5 there. This small little triangle is a 30, 60, 90 triangle. So that apothem length is the small base times root 3. So the surface area of that, the area of that base is 1/2 the apothem times by the perimeter, which is 60. So that all simplifies to 150 root 3 centimeters squared. So I basically add those two together to get that. Okay, our next example. Find the surface area of the regular triangular pyramid. I was trying to come up with as many examples as possible on this. So again, lateral area. 1/2 your slant height times by the perimeter of the base. I have 3 sides, they are each 6. So that is 72 square feet. Again, it is a regular triangular pyramid. So I have the base is an equilateral triangle where each one of the sides is 6. How I get my height, I drop down my perpendicular. Remember that makes now this side 3 and that side 3. I have a 30, 60, 90, so that is a 3 root 3. So the area of my base is 1/2 base, which is 6, times by my height, which is 3 root 3. And so that ends up being 9 root 3. So my total surface area is 72 plus 9 root 3 square feet. Okay, now a cone. A cone has a circular base and a vertex. So kind of like when we talked about cylinders. Cylinders had a circular base. Okay, now I have a circular base and we meet at a vertex. Okay, a right cone versus an oblique cone. Same thing, just an oblique cone's kind of like shifted over. Lateral surface area formula for a cone. Now this is actually a really important formula. I like deriving this. So the area of the sector is to the area of the whole circle. So the whole, if that was a whole circle, so the area of the whole bottom would be pi slant height squared. Okay, if this circle were to close, basically. The measure of the arc, the measure of that arc is 2 pi r. So the circumference of this circle is 2 pi times the slant height. Now if I take and I multiply, well first let's see what we can cancel on this right side. I can cancel those. And now if I take and I multiply by pi slant height squared, pi slant height squared, one of those slant heights cancels with one of those. We get, for the area of our sector, pi, that pi right there, the slant height times the radius. So what does that mean? That's our lateral area. So the formula for lateral area, pi r l. Pi, the radius of our cone, times by the slant height. The surface area is our lateral area plus the area of the base. Well, the lateral area is pi r l plus the area of the base is pi r squared. Find the surface of the cone, round to the nearest tenth. Interesting. I'm looking at this and I'm seeing that 3.2, and I'm going to assume that 3.2 is the slant height. So I'm going to have to do a little bit of math because my answer is going to be a little bit different than what I have in my notes. When I did this last night, I assumed that was that 3.2 is the height, but to me right now it's looking like that's the slant height. Okay, so my lateral area is pi r l. Pi times my radius, which is 1.4, times by 3.2 is equal to 4.48 pi. The area of the base is pi r squared. So that is equal to 1.96 pi. So my total surface area, I add those two together. Oh, it says round to the nearest tenth. I was going to leave it in terms of pi. Well, let's leave it in terms of pi. So I just add the coefficients, 4.48 and 1.96, and I get 6.45 6.44 pi. If I were to multiply that by pi, if I were to multiply 6.44 times pi, since they went it to the nearest tenth, I gotta have to make sure I read the directions. 20.3 centimeters squared. Okay, so for example 6 here, we have the whole diameter. They tell me the whole diameter is 12, so that tells me that is 6. They tell me that this height is 8. So to get my slant height, L squared equals 8 squared plus 6 squared. L squared equals 100. This is the one where I equaled 100. L equals 10, so that equals 10. Okay, so the lateral area, pi RL. So pi times by my radius, which is 6, times by my slant height, which is 10. So that's 60 pi centimeters squared. The area of the base is pi r squared, so that's pi times 6 squared, so that is 36 pi centimeters squared. So my surface area, I add those two together. Okay, and that is our surface, lateral area and surface area. Okay, now what I want you to do, I've given you guys a bunch of formulas now, and this chapter is really formula driven, as I said in the last video. So what you want to make sure you do now is copy down this chart and make sure you can fill in each one of these pieces of the chart for lateral area of our prism, cylinder, pyramid, cone, and then the surface area formulas. And you might want to make flashcards to practice and make sure that you know what the surface area and lateral area are.